Hello everyone, and today we're going to discuss a published agricultural study involving amines, amides, phosphates, sulfanes, and sulfonates. And a published study that we're going to discuss is about a basic biogenic aerosol precursor, agricultural source attribution of volatile amines, revised.
Despite recent evidence on an important role of volatile amines in the nucleation of particulate matter, very scarce information is available on their atmospheric abundance and source distribution. Previous measurements in animal housings had identified livestock husbandry as the main amine source, with trimethylamine or TMA in short being the key component. This had led to the assumption that the agricultural sources of amines are similar as for ammonia emitted throughout the cascade of animal exertion, storage and application in the field. In the study, we present the first micrometeorological flux measurements as well as dynamic enclosure experiments showing that the amine source strength from stored slurry is negligible, implying significant consequences for the global amine emission inventory. In the case of cattle, amine production is attributed to the animal's rumination activity, and exhalation is suggested to be an important emission pathway, similar to the greenhouse gas methane. Key points. Assumptions on the main global amine sources are challenged by true measurements. Cattle amine production is attributed to rumination activity. Vegetation in senescent state, high silage, is an important global amine source.
The formation of new particles through nucleation of gases is observed ubiquitously in the Earth's atmosphere and is an important contributor to the global aerosol number budget. Spracklen et al. 2008, Hallquist et al. 2009. It is linked to the production of cloud condition nuclei or CCN, which affect global climate by its direct and indirect net negative additive forcing. In classical nucleation theories, Sunfeld and Pandis 1998, basic alkaline compounds are assumed to significantly enhance nucleation by readily combining with acidic components like sulfuric, nitric, or organic acid. Volatile amines, methylamine, dimethylamine, trimethylamine, among others, are odorous, nitrogen-bearing organic compounds that represent the major residual of alkaloid constituents in the Earth's atmosphere, beside ammonia or NH3. Allied in a pioneer study with smog chamber in the late 70s, the light backscattering by particle was found to increase after addition of volatile amines, or Fetz al. 1978, but only recently the importance of amines in nucleons become evident. Angelo et al. 2001, Michele et al. 2001, Corten et al. 2008, Smith et al. 2010, Bizdek et al. 2010, Bent et al. 2010. Based on thermodynamic studies, volatile amines are considered to be more important for nucleation than NH3, even when the gas phase amines concentration are only thousands of NH3. Corten et al. 2008, she also Lukonen et al. 2010. Likewise, very recent experimental data gave evidence that small atmospheric salt particle clusters are most likely ammonium salts rather than ammonium salts, and amines rather than ammonia may be components of nucleation even in case where ammonium salts are performed initially. Bisdek et al. 2010. The attention paid by the aerosol scientific community towards volatile among strongly contrasts with the very scarce information available on their sources and atmospheric abundance.
Method: potential source of amine and NH3 volatilization from animal husbandry were investigated by cattle housing indoor air concentration measurements, double dynamic enclosure studies of various substrates in the laboratory, and triple the first micrometeorologically flux measurement after slurry application in the field using aerodynamic gradient method (AGM). Slurry is a composition of dung, urine, straw, and water. In order to characterize its emission potentials, both samples of slurry stored at the farm's underground pet collected prior to its application in the field, and double fresh rumen juice samples derived from fistulated cows were distilled by addition of NaOH, subsequent steam heating, and transfer of the vapor phase to a gas collection mean of H2SO4 0.5 m.
Result and discussion. Animal housing indoor concentration. In our measurements, the abundance of amines, both ambient air concentration and emission rates, was always strongly dominated by TMA, 50 to 80%, as has been reported in earlier publication for concentration in animal housing and feedlots. Other observed amine compounds were dimethylene, monomethylamine, and ethylamine, with MAA showing the highest relative variability. Even though not all amines covaried to exactly the same ratios and thus may not have fully identical sources, we consider TMA as a key compound for assessing the budget and characteristic of atmospheric amines. Our observed TMA and H3 concentration ratios in cattle housing were found to be in a range of about 0.3 to 1.0%, confirming earlier observation of enhanced amine concentration in indoor air. While these findings lead to the assumption of similar source mechanism for amines and NH3 from animal husbandry in earlier.
Both are result after application of slurry in the field, over grass and cropland by means of a micrometeorological flux method, figure 1 top, as well as corresponding trace gas exhales measurement on fresh cattle dung in the laboratory by means of a dynamic ensure system. Figure 1 bottom showed that TMA emission exhibited a temporal trend similar to NH3 point peak emission were observed in an essential phase of a new hour, followed by an exponential decay of emission. However, the respective TMA over NH3 emission ratios never exceeded 0.01%, and those were about to add orders of magnitude lower than expected from the animal housing indoor air concentration measurement. Accordingly, low TMA over NH3 concentration ratios 0.0018 over 0.0035% table 1. We also found this distillates of samples from the farm slurry that were taken directly prior to its application in the field, confirming the low amine immersion capacity. TMA fluxes in the field were low to be resolved with the EasyFlux method by means of PTRMS detection. We conclude that the emission from dung and slurry cannot explain the observed enhanced amine concentration in the animal housing.